You want to find the equation of the line perpendicular to 3x plus 2y equals 11 that contains the point -1, 4, and express the answer in slope-intercept form. So we're going to start with the equation 3x plus 2y equals 11. And we'd like to identify the slope, so I can put it in slope-intercept form. Let's subtract 3x from both sides. So we get 2y is 11 minus 3x, or better, -3x plus 11. Then we divide by 2, and we get y is -3/2 x plus 11/2. So my original slope, remember y equals mx plus b. My original slope, my original m, is -3/2. So the slope of my first line is -3/2. So my original slope is -3/2. But I want something perpendicular to that. So what do we know? To determine the equation of a perpendicular line, you change the sign and flip. Opposite reciprocal. Negative becomes positive. Flip 3/2 to give us 2/3. So we believe that the original slope we have is -3/2, and we believe a perpendicular line will have a slope of 2/3. So let's take a look at Desmos and try to convince ourselves that we're right so far. So here is my original equation. 3x plus 2y equals 11. And what is our slope going to be here? Kind of difficult to see. I guess we have a point here at 1, 4 that's crossing at a hash mark. And we have another point here that seems to be crossing at 3, 1. So if that's the case, slope down 3 over 2, change in y, down 3, change in x over 2. So our slope seems to be -3/2, which is what we said, right? We said for our original line, the slope was -3/2. Now perpendicular, we said the slope should have to be 2/3. So let's just draw a line with slope of 2/3 and ask ourselves if this looks perpendicular. Now you need to make sure that your axes are the same size, that you're not like in a circus funhouse mirror where x is stretched differently than y. But in this case, you'll notice the slope is 2/3. This slope is -3/2 of the purple line, and they do appear to be perpendicular. But what I need to do is I need this perpendicular line to go through the point -1, 4. So -1, 4 is here, so you can see I'm going to need a line that looks something like that. So through -1, 4 with the slope of 2/3. So let's find the equation of that line. So again, the point is -1, 4. The slope of the perpendicular line is 2/3. I expect many students will want to use point slope form. Y minus y1 is m times x minus x1. Y minus 4 equals 2/3 x minus -1. Y minus 4 is 2/3 x plus 1. And I always like to do it in slope-intercept form. That's my preferred strategy since that's equivalent to function strategy. 2/3 times x is 2/3 x plus 2/3 times 1 is 2/3. Then we need to add 4 to both sides. Add 4 here. Add 4 here. So we get y is 2/3 x plus 2/3 plus 4 is 14/3. And remember, I actually prefer to solve it a little differently. If I have the point negative 1, 4 with a perpendicular slope of 2/3, I prefer to use y equals mx plus b. Solve for b, plug in 4 for y, 2/3 of negative 1 plus b. 4 is negative 2/3 plus b. Add 2/3 to both sides, and you'll notice it's equivalent. And I get 4 plus 2/3, which is 14/3 equals b. But that's not my answer. If you're going to use a strategy, remember, that's the slope, that's the intercept. So I have to write my answer as y equals mx plus b, y equals 2/3 x plus 14/3. So let's go back to Desmos and see if it goes through our point of interest and see if that line does look parallel. So remember, our first attempt at a line with slope of 2/3 was y equals 2/3 x. I need to add 14/3, and the hope is if I add 14/3, it's going to go through that point. Does it? It sure does. So this point here, negative 1, 4, I guess I put a label on it as well. So there's all the points that we're working with here. So the red line is perpendicular to the purple line, and it goes through the point negative 1, 4. Our equation in slope-intercept form is y equals 2/3 x plus 14/3.